Hello, and in this video we're going to cover the concept of a function. This happens in section 2.1 of your textbook. Now the definition of a function is it's a relationship between two values in which the first value has only one corresponding value to it. So that means if you assign a value to if you're given a value, you're only going to have one answer for it. An example of that would be this problem right here, this mapping. 10 only maps to one thing. -7 only maps to one item. 5 only maps to one item. 0 only maps to one item. This is a mapping of a function because each one of these values only has one value as its answer. So this is a function here. Whereas in the second example here, this is not a function because of the first number here. The first number, 19, has two different answers. So sometimes the answer to 19 is 0, and sometimes the answer to 19 is -3. So this right here tells me that it's not a function because this value has two different answers coming out. Now, in this mapping, the first part of this, the first set is called the domain set. So this is the domain of a function. This is the domain. The domain here is 10, -7, 5, and 0. The range are the answers or the outputs. So we also think of these as input and outputs. So the domain is called independent variable and the range is called a dependent variable. And also the domain can be called an input variable and the range can be an output variable. This is the domain here. This is the range here on this example. Now in the table of values, the domain is in this column. This is the domain. And the domain, and this is the range values. Here's me abbreviating already. And these are the range values. Okay, so if we look at the domain values, we want to see if they are being mapped. So we want to look at these values here and see, we want to look at these values, all of them, including the 16, and see if there's any mappings that are sending them to two different values. So we look at this list and say 3. 3 only goes to -2. 5 only goes to 0. -1 only maps to 4. 16 only maps to 5. So this is a function. This is a function. Because each value only has one answer. So this is a function. Now, over here we have a problem. This right here is going to a value of -2, and then later on in the list the same value is going to 4. So this is not a function because of that 3 value there. It's not a function because of that. Now still the domain values here are 3, 5, and -1, and the range values are -2, 0, 4, and 5. Even though it's not a function, it still has a domain and range. And we just list them out in pairs or in a list. Now we can also make a chart look like ordered pairs. So this could be just the same type of problem here, but it's not in a table value, it's in a list of ordered pairs. We would still be looking at, do we have mappings that are setting -2 goes to 5? Is there another -2 in the list? No. So that value is helpful or is okay for the function. This one's 3 sending to 0. Is there another 3 later on the list? There is. So this is a problem. This is not a function because 3 is sent to 0 here and 3 is mapped to 7 later on. So there's not one answer for 3. So this is not a function because of that 3. Now if we look at this one, we have -2, no other -2 mapped anywhere, 2, no other 2 mapped anywhere, -1, and 7. So this one is a function because it doesn't have any problems with the mappings. We don't have any problem finding one answer for each value. We have one answer for each value. It could be the same answer. They could all be mapped to 5, but that's okay to, if -2 is mapped to 5 and 2 is mapped to 5, it's okay to have the same values on the outputs, just not the same input values that give you different output values. All right, so the domain of this example right here is -2, 3, 4. We don't say the 3 twice. And the range is 5, 0, -2, and 7. In this example, the domain is -2, 2, -1, and 7. The range is 4, 1, -9, and 7. So that's the domain and range of that pair. Okay, on a graph, we're looking for the same type of thing. We're looking for a mapping. So no points should be above each other. This is one x value mapped to a y value, one x value mapped to a y value. So this is a function here because every one of the x's only has one y. When we run into a problem is when we have two x or the same x value being mapped twice. Here's our problem in this one. This x value has a mapping right here on a y and a mapping right here on the y. So it has the same x value but there's two different y values. So this is not a function. So anything that's mapped above each other, it's not going to be a function there because it's giving you two different answers for the same x. Okay. And the final thing here on this part is to take an equation and determine whether it's a function of y. So we're looking here at determining whether an equation is a function, defines y as a function of x. That means if we put an x value in there, we should only get one y, only one answer for every x value. So if I put in an answer here like 7, well, let's try a number that we can easily do. So if I have y squared equals, let's put 8 in there. So 8 plus 1, let's just try 8. 8 plus 1 is 9. So my answer for y here is the square root of 9. But remember, when we take the square root ourselves, there are two different answers that work, plus and minus. So this is not a function because we have a plus and a minus. We got two answers out of this. Now if we put an answer in here, like 5, we're going to get 25, and then we're going to add 4 to it, and we only get one y value. So this is a function because we only get one answer for every x value. Now the key there is that if we have a square root, that's possible to get two answers out of, a plus and a minus answer. That's when we're not going to have a function. All right. Here we're not going to take the square root to solve for y. All we have to do is subtract 4 to solve for y in this problem. So we're not going to have two answers because when you're going to add 4. Add 4 to get, you're going to have y equals x squared plus 4. There's only one answer. For every x I put in there, I'm only going to get one answer for y. Now if I had this one and I solved it, I would just take the square root. So this one simplifies into y equals this plus or minus the square root of x plus 1. And there's two answers to that, a plus and a minus answer. So that's the issue there, is that you're going to have two answers to this because you have a plus and a minus.